before we get into the lesson, let's review what type of motion we have learned in the 10th grade circular term. In 10th grade, we learned about uniform motion, uniformly accelerated motion, and a circular motion. Thank you, Professor. Now I invite you to watch the videos and tell me what are the characteristics of the object's motion. Who will here address this question? Yep.
I can see the object move around the central position.
Yeah. What is argument? So, the object moves like it. Oh, thank you. Now we continue to watch the video, another video and tell me what are the ball can hit the face.
And I cannot move any further back, so there's no cheat here. I'm going to release it right from my chin. You realize, as you have just seen, that the slightest push, and this will be my last lecture, and no book signing afterwards. And I have to tell you something. I couldn't sleep all night. I'm going to close my eyes. I don't want to see it. And I'm going to count down from 3 to 0.
So, can you answer the question?
The ball is doesn't hit the face.
Oh, thank you. Great answer. To answer this question, let's begin the lesson. Lesson 2, describing equilibrium oscillation. Now, in previous lesson, you have learned the equation of oscillation. Can you remind me of this equation? Can you write the record?
Omega is the angular frequency. And phi is initial phase.
tracking function. Can anyone summarize for the class how to review the tracking function in course 7? Who volunteer? Yes?
Miss Anh, first I have to import the video and open post 7 and load the video you want to edit. Next, select the object to track in the timeline to the video and drag it into the editing window. Then select the object or area in the video that you want to track, and finally enable tracking and run tracking in the control panel. Find the tracking or motion tracking session and choose the tracking mode. For running tracking, click the track button and to start tracking the object. Code 7 will automatically analyze the movement and create tracking point on the object. And the graph session, we can observe the graph set of the motion.
Oh, thank you. And can you come here and carry out this step to class to see the detailed step?
Yes.
Now I will divide our class into 3 groups. A group must use the provide equipment, experimental video along with the research concept software to plot the XT graphs of motion and observe X graph. So, group 1 will work on horizontal spring mass in that order. Group 2 will do the vertical ones, and group 3 will handle the remaining part, the single pendulum. Now I can note this in the black box to you attention. Group 2, can you answer this question?
Vertical spring mass.
Okay, after plotting the graph, I want the class to compare it with the sample graph and answer the question in the worksheet that have been distributed to each group. Now it's time to a group. This question with teamwork.
Phiên bản đấy phiên lên không phải
Okay, I noticed that all 3 groups are working very efficiently and quickly completed the worksheet. Now I want our class to form 3 new groups. You can move as well as a group has one or two people from group one or two people from group two, and the same for group three. This means that a still group could have members from all three old groups. Okay, after forming a group, the members will share the results they have gathered and express in the peer. After 5 minutes of discussion, share the results from the three groups and complete the summary table on the back of the worksheet. Then I will randomly call a student from a new group. The one I refer to as the two group to report. I had a question to you is to fill the worksheet in the back of the worksheet this is the table you first review after you in the discussion and in the jigsaw book. Complete the discussion activity. Each student in three groups can report the results to find after discussions. Group one can you?
After discussion, my group have the conclusion that after using tracking function code 7 to examine the displacement graph over time of the spring pendulum, my group got the graph as shown on the board. It is a sideways graph. Then based on the simple graph as so in the statistics, I determined the amplitude of the horizontal spring pendulum to be 5 centimeters, and from there I derive the definition of the amplitude is the maximum displacement of the object from the equilibrium position, and compare with the graph above. It is the maximum value of displacement x, denoted by a next, based on the sample graph, I determine the period of the spring pendulum is to be 1 second. From there, I define the period as the shorter period of time for an object to perform an oscillation. This yes, it is denoted by yes, it is denoted by t, and unit of this is the second. As for frequency, as I have learned frequency in the inverse of a period, and based on the definition in the textbook, I have concluded the number of oscillation performed in 1 second is called the frequency of the oscillation. The unit is hertz, and in this case, frequency of the horizontal spring pendulum is the 1 hertz.
Okay, thank you. The answer of the group one. Or about group two?
After using code
7. Our group got the oscillation graph of the pendulum as shown in the board. The graph of my group also has a sinusoidal shape like that of group 1. Our group determines that A equal 4 centimeter, which is also the oscillation amplitude of the pendulum. As the period of the pendulum, we determine the value of the period to be 4 seconds. From that, our group also determines the frequency to be 0.25 Hz. Regarding the definition of the period and the frequency, our group is the same as group 1. The maximum magnitude of the displacement. The maximum magnitude of the displacement is called the amplitude of the oscillation. Symbol A. The time it takes for an object to perform an oscillation is called the period of the oscillation. Symbol T. Unit second. The number of oscillations performed in the 1 second is.
Okay, about group 3, can you have some comment about the answer of group 1 and group 2 about the definition of the maximum magnitude of displacement or the parity and the frequency F? Can you give some?
After using group 7, our group got the oscillation graph of the pendulum as shown in the picture. And the graph of our group also has a sinusoidal shape like group 1 and group 2. And our group determined that A equal to 4 centimeters, which is also the oscillation amplitude of the pendulum. As for the period of the pendulum, we determined the value of the period to be 4 seconds. And from there, our group also used the frequency to be 1/4 Hz. And regarding the definition of the period and the frequency, our group is the same as group 1.
Okay, thank you. The answer of the 3 group. And now you write the definition of 3 components in the book.
proceed.
Third point. In a second. And is serious in task. Tom, can you find a real textbook and from the graph I draw in the black box, can you answer me what is the initial point of this graph?
I can see that the at t equal 0, I can see uh, uh, the object at equilibrium position, and it is moved to and positive amplitude, and the initial phase of the motion is minus pi per 2.
Okay, thank you, Liz. And so I can remind you the definition of the initial phase. Is a phase of the vibrating particle corresponding to time t. Equals 0. After you have completed the dispersion activity and see the results, please use the periodicity in the quotient function from the textbook to find the expression that relates relation of omega and t. Find the relation between omega and t. In this graph, and the numbers about the cosines. Can you answer these questions? Can you answer this? So in the box?
We have the cosine is the periodic function. Cosine is
In the shape of the scenario.
we have the cosine is the periodic function, so we have the cosine of the angle theta plus the 2 pi is equal to cosine of theta, and we also have the cos of omega t plus t t is equal to cos of omega t plus t, and to find the t, we require this equation must be satisfy the omega t plus omega t is equal to omega we will use this, and we have the third to nine. In this we have the omega t plus t plus the 9 equal to omega t plus 5 and plus 2 pi. And from this we will remove the omega t and pi, and we can conclude that the omega t is equal to 2 pi.
Thank you. Thank you, this answer. Great. Okay, from topic results, I can define to you what is angular frequency. Angular frequency. Omega is the rest of angular. It's like in trains. And its units in radians per second. And the equation to find the omega is 2 pi over t. Okay, now from the two separate graph 2 and graph 3, I can draw both of them with graph 2 and 3 from the same tracks. Like this, and extended right, this graph is invertible. Now I will draw the graph 2.
V1 and V2.
At t equal to 0, we can see that the motion one is start at the displacement at equal to 2 centimeter, and this is equal to a half of amplitude, and it is moved to the whole positive of amplitude, and the phase of initial phase of motion on equal to minus pi to 3.
Okay.
And
Graph 2.
the similarly, we can see the initial phase of motion 2 is equal to minus pi to 2.
Okay, thank you. And so now I can compare the phase of the motion 1 and motion 2 like this. Omega t minus p over 3 and minus omega t minus p over 2. Then this equation equals to the minus p over 3 plus the p over 2. And the answer of this equation is pi over 6. Now here, this is the differences from the P1. It's P1 minus P2. And it is defined by delta P. So I can define the delta P is the difference of P1 and P2.